So we are going to start question number 7. Solutions to this equation by accurate drawing will not be accepted. So you don't have to show anything using drawing, right? Okay. A circle has equation x squared plus y squared minus 16x minus 10y plus 73 is equal to 0. And in part A, part 1, we have to find the coordinates of the center of the circle and the length of the radius. So we have equation x squared plus y squared minus 16x minus 10y plus 73 is equal to 0. So we have to write x squared minus 16x together and y squared minus 10y together so that we can change it to completed square form. So when we will change this to completed square form, we will be writing x from here minus, we will divide it by 2. We will write here, then whole square. And then we write square of 8 with minus sign. Then plus y, we'll take y from here. We'll divide it by, we'll write the minus sign. We will divide it by 2. We'll write whole square. And then we will write minus with 5 square. And plus 73 is to be written as it is. So we will write x minus 8 whole square plus y minus 5 whole square minus 8 square will be minus 64. We will write constant terms together. Minus 5 square can be written as minus 25 plus 73 is equal to 0. So we have here x minus 8 whole square plus y minus 5 whole square minus 16 is equal to 0. So finally, we will have x minus 8 whole square plus y minus 5 whole square is equal to 16. So now we can write the coordinates of the center of the circle. 8, 5 are the coordinates of center of the circle. We have general form of the equation as x minus a whole square plus y minus b whole square is equal to r square. So this 16 is basically r square, right? So we have r is equal to 4. Then hence show that the point 10, 6.5 lies inside the circle. For this, we need to find out the distance from center to this point, right? So 10, 6.5 and 8, 5. So we will find out the distance using distance formula. Distance is equal to under root 10 minus 8 whole square, the difference between these two, plus 6.5 minus 5 whole square. So this is 2 square plus 1.5 square. So finally, the answer would be 2.5. Now the distance from center of the circle from center of the circle and the point 10, 6.5 is less than the radius that is 4 units So point lies inside the circle. This distance must be lesser than the radius. If it is lesser than the radius, it means that the point lies inside the circle. Now we are going to do part B. Our different circle has equation x minus 10 whole square plus y minus 6.5 whole square is equal to 2.25. Show that the two circles touch. You are not required to find the coordinates of the common point. For your understanding only, I have drawn this circle. Otherwise, it is not required in the question. So if you see this circle, r square is 2.25 and radius is 1.5. The coordinates of the center of circle are 10, 6.5. Now, if you have to show that the two circles touch, we have to find out the difference between the two radii, right? So one of the radius is 4 and the radius of this circle is 1.5. Now we will take out difference between the two radii. So difference is equal to R1 minus R2. So R1 is 4 and R2 is 1.5, so which is 2.5. If the distance is equal to the difference between radii, then two circles touch each other. So now we are going to do question number 8 in part A, part 1. We are saying show that cos square 2x upon 1 plus sine 2x is equal to 1 minus sine 2x. So first of all, we will take cos square x is equal to sine square 2x, which is an identity. There's cos square x plus sine square 2x is equal to 1. In the denominator, it would be 1 plus sine 2x. Now we have to factorize this using an identity. It is a square minus b square. So a square minus b square is equal to a minus b and a plus b. So we can write here 1 minus sine 2x and 1 plus sine 2x. And in the denominator, it is 1 plus sine 2x. So 1 plus sine 2x and 1 plus sine 2x is to be cancelled out. So we are left with 1 minus sine 2x. So it is proved that this is equal to 1 minus sine 2x. Now in second part, they have said hence. Hence solve the equation for 3 cos square 2x upon 1 plus sine 2x is equal to 1 for x is greater than or equal to 0 and less than or equal to 90 degrees. So if they have used here the word hence, it means whatever you have done in the previous part is to be used over here. So first of all, we will see that this cos square 2x upon 1 plus sine 2x is the same as given in the first part. So we can replace as this by 1 minus sine 2x as it is given in this, and we have already proved it. So in place of cos square 2x upon 1 plus sine 2x, we can write 3 into 1 minus sine 2x is equal to 1. Then we can solve it. We have 3 minus 3 sine 2x is equal to 1. So now we can take 1 on this side and 3 sine 2x on this side, so it will become positive. So 3 sine 2x is to be positive and 1 is to be taken on this side. So 3 minus 1 is equal to 2. So that is equal to 2. So we can write on either side, right? So then sine 2x is equal to 2 upon 3. Now here we have compound angle, so we can take a is equal to 2x, and then our equation will become sine a is equal to 2 upon 3. So now we will take out basic angle alpha. Alpha is equal to sine inverse of 2 upon 3. So which is equal to 41.81. The value of sine A is positive here, and sine is positive in first and second quadrant, and they have given the range here from 0 to 90 degree. It means that we have to find out angle in first quadrant. So in first quadrant, theta and alpha are equal. So we have here A is equal to 41.81 and 2x is equal to 41.81. So x is equal to 41.81 divided by 2. So it means 20.9. So the value of x is 20.9. Now in B part, they are saying solve the equation cot y minus pi upon 2 is equal to under root 3, where y is in radians and the range is from 0 till pi. It means that first and second quadrants are included. Now, if they have given cot y minus pi upon 2, so we can change it into tan y minus pi upon 2. A cot is inverse of tan, so it means that when we'll change it into tan, then it will become 1 upon under root 3. Now this is a compound angle, so we can take it as A is equal to y minus pi upon 2. So our equation will become tan A is equal to 1 upon under root 3. So now we have to take out basic angle alpha by taking tan inverse of 1 upon under root 3. So alpha is equal to tan inverse of 1 upon under root 3. And so alpha is equal to 1 upon 6 pi. We have to consider first quadrant because tan is positive in first quadrant and in third quadrant. But the range is given from first quadrant till second quadrant. So we'll just be considering the first quadrant where theta is equal to alpha. So we have A is equal to 1 upon 6 pi. So now we will replace A by the angle which we took in the starting. So y minus pi upon 2 is equal to 1 upon 6 pi. So y is equal to 1 upon 6 pi plus 1 upon 2 pi, which will be equal to 2 upon 3 pi. Now we'll do question number 9, in which there is a diagram given, which is not to scale. And they are saying the diagram shows a rectangle ABCD and an arc AXB of a circle with center O. This is center O and this is an arc of that circle. The midpoint of DC. O is the midpoint of DC. The length of BC is 8 centimeter and the length of DC is 30 centimeter. And angle AOB is theta radians. If this is 30 centimeter and they are saying that O is the midpoint of DC, so it means that this is 15 centimeter and this is also 15 centimeter, right? And then BC is 8 centimeter. If this is 8 centimeter, this is also 8 centimeter because it is a rectangle. By using these two values, we can find out this radius of the circle, which is having center as O and AB is an arc of that circle. So for that, we need to apply Pythagoras theorem. So if we say that this is R, so R square is equal to 15 square plus 8 square. And so R is equal to under root 15 square plus 8 square, which is equal to 70. So it means that the radius of the circle is 17 centimeter. Now, they have asked to find the perimeter of the shape ADOCBX. So it means that we have to find out the length of this. We have to add up all these lengths, right? So we'll see which of the side is missing. We'll be taking out that side and then we'll be adding all the sides. Starting from here, we have AD, which is 8 centimeter. We have DO till C, 30 centimeter. Then we have CB, 8 centimeter. We want this AB. AB is arc length. And for arc length, we need to have this angle, right? Which is theta radian. So we need to take out this angle. If we take out this angle in this right angle triangle, then as we know, this is a rectangle. So we have here right angle. And because of this, we took out this radius using Pythagoras theorem. So if we consider this triangle, we will be able to find out this angle, right? And this angle would be same because both are congruent triangles, right? They both have same lengths and both are right angle triangles, right? So first of all, we will take out this angle. To take out this angle, we have this side and which is adjacent and this one which is opposite. So we can apply here tan. We have to take out this angle, so we can consider here AOD. Tan AOD is equal to perpendicular upon adjacent, which is 8 upon 15. So AOD is equal to tan inverse of 8 upon 15. So we have here 0.48995. We have to take here, we have to use radian mode to find out this angle, because whenever we do circular measure questions, we have to use radian mode because the angles are in radian. So we have taken out AOD, which is 0.48995. So this is 0.4895. So this is also 0.48995. The sum of all these is equal to pi. That is equal to 180 degrees. So we in radians we say pi. Pi minus 2 into 0.48995. So which is equal to 2.1616. So once we have got this angle, we can now easily find out the arc length, which is AXB. So AXB is equal to r theta. So we have radius is equal to 17 and we have theta is 2.1616. So which is equal to 36.7485. So now we can take out perimeter. So for perimeter, we have 8 plus 30, 8 plus 30 plus 8, and then this arc length. So finally, we have got here 82.7485. The three significant figure, we can write it as 82.7 units, right? Centimeter, because it's given in centimeter. In the B part, we have to find the area of the shape ADOCBX. We have to find out the area of this whole shape, right? Now you can see that this whole shape, consider this one sector and these two triangles, right? So we can easily find out the area of these two triangles because we have base, we have height. So we can simply find out by using half into base into height. And for this sector, half into r square theta. So simply we have to take out area is equal to half into base into height. And there are two triangles. So we'll be multiplying it by 2 and plus 1 upon 2 r square theta. So this and this will be cancelled out. So simply we'll be left with base and height, which is 15 into 8. Then we have plus half into r square. Radius is 17. So it is 17 square multiplied by theta is 2.1616. So we have all the values over here. Now it will be 120 and it is 312.3512. So we have 432.3512, and if we'll round it off to three significant figure, it will be 432 centimeters square.